All right, so then that said, like I said, today we're just going to go over some plotting stuff. Let me look at my so at this point, all I've done is run this stuff up here at the top, and then I ran each of the models so that I have them stored already. Let me look over at my notes and see. So the plots that we ended up making yesterday. You know, we worked through. We worked through, and this plot in and of itself isn't particularly pretty. It was just showing various things. You know, originally it wasn't faceted. Then I was showing you do want to facet it and adding subtitles and titles and blah, blah, blah. One thing that I do want to point out that I talked about yesterday was like when you do facet things, if you choose to facet things and like these facet labels, they're not the easiest thing to change, like what the labels of the facets are. If it's at all possible, the easiest thing to do is just make sure whatever that variable was labeled in the data matches whatever you want your facet labels to say. So in this case, like in the data, it's lowercase female and male, but if I was trying to make a publication quality plot, I would want to capitalize those. So the easiest thing to do would just to be to recode that to make it capitalized in the data. But I talked about there are roundabout ways to change it after the fact. And so I added this onto the Thursday script that I've posted on Blackboard, because basically instead, in some of my plots, I've had situations where like changing it in the data isn't as straightforward and easy as it seems. Don't need to get into why. But basically, like I wrote a helper function called plot labeler, and then like I just changed my like what the labels I want. And when I run these two lines, now if I take the same code for this plot and literally just add labeler equals plot labeler, which is this function that I created here in this list, when I run it, it will now you know, change those facet labels. So just know that there are ways to change those particular facet labels if you need to. It's not necessarily straightforward. So if it's possible, the easiest thing to do is just to change to whatever you want your facet labels to be. And so yesterday we looked at age as the x-axis and breaking it down by gender. And then we also looked at class by gender. So we're looking at the Titanic data set, you know, whether or not they survived based on age, gender, and class. And so for today's, I have three options, and I'll let y'all decide like which ones you'd rather see to make sure that we get through that one. But we can do gender on the x-axis with, you know, the dots and bars for say plus and minus 1 standard deviation of age. So when you're looking at some specific value of a continuous variable, basically the inverse of this chart where we have gender on the x-axis and prediction models for each of the three classes broken down by male and female, or like the previous graph where we have age on the x-axis, but instead of breaking it down by male and female, having different prediction lines for first, second, and third class. So y'all tell me which one you want to start with.
I would like to do the male and female on the X and then color coded by class.
Okay. So if we are wanting to do, I guess I need to be on the right computer. So if we are wanting to do X as the sex and broken down by class, different predictions for those. All right, so the place that you always want to start is just by building your base plot. In this case, we're going to say ggplot and beam classic. This is how I always start. And then we'll do geom jitter, data's Titanic. And we want our X to be sex and Y to be survival, or survive.
Can you go just a little slower?
Yeah.
So what you're doing is just, that's the base, you're plotting like the straight up raw data.
Yeah. And so just having a base plot here. And so like right away, I see like, okay, I want to make some adjustments, even just this base plot. Specifically, let's set our height to, let's try 0.1 and our width to, let's say 0.1 also. See what that looks like. All right, so now we're clustered. We're going to want to change our alpha, which is the transparency, so that you can see that overlap. So let's say our alpha equals 0.2. See what that looks like. Cool, so now we can see like where there's a lot more overlap. That's a little bit more clustered than I'd really like it. So maybe I'll make that a little bit wider. Change that width to 0.2. Maybe even make it a little taller, 0.15. All right, cool. So now we have a little bit more visual distinction between these things. And we also want to break it down by class. So it's probably not a bad idea to color these dots by class. So one of the things I talked about yesterday was making sure that we're all tracking with like what these aesthetics are, what you put inside AES versus what goes outside AES. So what it comes down to is remember that what the aesthetics are, this is a way of telling ggplot, there's something that I want to have on the graph that is a direct function of what's in the data. So if I want to color it based on what the value of that particular data point is, or if I want to make a shape or the size or anything, I want it to depend on what is in the data, that is an aesthetic. If it's something that the data is irrelevant to it, then it's not an aesthetic. So for instance, if I just want everything to be red, regardless of what it is, that's going to go outside my aesthetics. And I would just say color equals red. And now it's just going to make everything red. But that doesn't go in aesthetics because it doesn't matter what the data says. It's just making everything red.
Looks like different shades of red here.
That's because I have the alpha. So they're all the same shade. Where they look darker is because there's 2 points that are overlapping. So that's what that alpha gets you. It allows you to see the overlap in dots because the darker it gets, the more there's concentrated dots there. Yeah. Now, if instead I do want the color broken down by some specific variable that's in the data, that's when it becomes an aesthetic. And I'll say color equals class. And now it will break down that color based on what your class is. All right, so now like we have a pretty good.
Can I ask a question?
Yeah, what's up?
So the height and width, can you put it over with?
Yeah, so that's just that's adjusting how wide, because what the jitter does, if we
That's a single point in the middle.
yeah, if we take this and instead I'm gonna hashtag this out, and instead I'm just gonna make this geom point instead of geom jitter, which means I take out the height and width. If I run that instead, like it literally just, because everything is either 0 or 1, and it's either female or male, so just everything is completely overlapped. So what the jitter does is it adds some random variation to the points and allows it to move away from its actual exact point. So your width and height tells R how much to let it randomly vary from that. So if we make the height 0.05 instead of 0.15, you'll see that now it only lets it go up and down 0.05 units.
And does that depend on the Y scale and X scale then?
Yeah. Yeah, and so that's something that's important to keep in mind, because if you're on a 0 to 100 axis scale, just like if you're making a sequence for breaking something up, you wouldn't use 0.1. In fact, we'll see this when we talk about the age. When we were making this plot, when we make our sequence, we don't need a sequence from the minimum to the maximum broken down by 0.1, because even if we break it down by whole units, we still have 80 separate points along that x-axis. So here, if we were using a jitter thing here and we said that it's, the width is 1, it's only going to let it jitter from here over to here. So in this case, like the jitter might need to be, 10 or whatever. And so, yeah, really all it comes down to is playing with these values and just looking at the plot and going like, no, I want to increase that dispersion a little bit, or that's a little bit too much, I want to decrease it. Because if we instead put the width at, if we change our height to, 1, now we don't have a clear distinction here of what's in what group. Even if we make a little bit bigger, but not quite that big, and say like 0.6, it's still, it's visually misleading. It's hard to see what belongs in what group. And so really it just comes down to playing with it and figuring out at what point is what you're trying to show intuitive and clear. You want to be able to very easily identify oh, these points all belong together. That's one group of data, and this is one group of data. But you don't want it so compact that you can't distinguish anything in there and just see oh, it's all just a ton of overlapping data, but I can't tell how much it is. All right, so now we have our base plots. So now we need to get our predictions, and we want to break this down by class. So now I'm going to come back up here above it, and we're going to start by making our plot df. I'm going to call it 3 so that it doesn't mess up what's already in my environment from Thursday's scripts. And here's where we're going to use expand grid. Now, as a reminder, what expand grid does is it takes everything that you put inside expand grid and outputs every combination of those things. So what we're wanting to do is, if we're taking the sex by class model right here, mod SXC, we have sex.f and class as our 2 variables. So we need to create a data set that has those 2 variables and has every combination of those variables that we're wanting to make a prediction for. So in this case, we need a prediction for, females, 1st, 2nd, and 3rd class, and males, 1st, 2nd, and 3rd class. So how you do this, there's all sorts of ways you can do this. You could just say sex.f equals male, female. This, in this particular case, is the same as saying, for instance, sex.f equals unique Titanic sex.f, which unique just returns all unique values of whatever. So if I said sex.f equals Titanic sex.f, if you look at what just putting in Titanic, if you run just Titanic sex.f, it puts out 800 values of things. But when you say unique Titanic sex.f, then it will only output 1 of each unique value in that thing. So here, instead of saying sex.f equals male female, you could say sex.f equals unique Titanic $sex.f. Point is, you have to tell expand grid, I want two values for sex.f, and those values are male and female. Then I need.
Sorry, that's going to output the same number of rows as your original.
If you just put in, well, I'll just do this. Yeah. And then down here, class, we'll just say 1 through 3. See, now our output is 500 things long. Instead, if we put unique, then there's only two values for sex.f. And so now when we look at our plot df, it gives us what we're looking for, which is male first class, female first class, male second class, female second class. So now we have the start of our plot data frame for our predictions. If we were, and when we here in a little bit, when we look at like a continuous variable, that's when you got to do one of two things. You either need a sequence of values, like if you're plotting if your x-axis is continuous and you're wanting to plot different models with confidence intervals, and that's when you'll need a sequence. If you're looking for specific values, if you're wanting to plot plus and minus 1 standard deviation, then what you have to do is figure out what is plus and minus 1 standard deviation. So if, for instance,
Sorry.
go ahead.
Where you got that 500 output thing, what did you do differently?
I didn't wrap this in unique. I just said sex.f equals Titanic $sex.f. And so this on its own, if you ignore the unique part, this part right here on its own is, however many data points there are. There's, 800 occurrences of either male or female or whatever. And so if you just say that is that, then it sees this huge, it actually gives like that output 2,500 rows because it was 800 values of male and female crossed with, 3 values of class. And so by using the unique function, it only allows any level one time, or you could just say C parentheses male comma female. But if you were looking at age, you could either specify, whatever, if you do the math and you see what plus and minus 1 standard deviation is, mean Titanic age plus standard deviation Titanic age. So the plus 1 standard deviation is 43 point whatever. And then if you change that to minus, it's 15.34 is minus 1 standard deviation. So you could do this if you're trying to model plus and minus 1 standard deviation. Or you could say that, this is C and just put it straight into the function instead of manually inputting those values. You can just tell it, and this will give you the exact same output. So if you're looking for, 2 specific values of some continuous variable, then you'll go this route. If instead, when we made that other plot, where the continuous value is the x, that's where you need a sequence because you need to divide it up. You need a way to tell it, like we want a prediction and a confidence interval for this value and this value and this value and this one and this one and this one. And then you're basically just connecting together those 100 different predictions. So if that was the case, then you would be doing a sequence from, say, the minimum of Titanic age to the maximum of Titanic age. And so when you do that, now it will give you a prediction for 0.42, 1.42, 2.42. And so again, like now you have a prediction as well as an interval for this spot, this spot, this spot, this spot, this spot.
So that's going from minimum to maximum age divided up by 1 unit in between?
Yeah, which is the default. Now, if our continuous variable was, say, only 1 to 5, if we were looking at like how many spouse, siblings, or children you have on the ship, and so X only goes from 1 to 5, if we did this and just said minimum from that to that, and so it would just say 1, 2, 3, 4, 5, now our expand grid, or when we make those predictions, all we have is one prediction at 1, like here's the mean, here's the interval, and then over at 2, here's the mean, here's the interval, and 3, here's the mean, here's the interval. And it's just going to connect those points with straight lines instead of breaking it up into smaller chunks. So if that was the case, that's when you would add, something like 5 equals, 0.5 perhaps, where now you're breaking it up into smaller units, or if that's not enough, by 0.1. And so you just have to stop and think about like, okay, what's the range of the x-axis here, and how fine do I need to break this down so that I don't have a jagged thing so that it looks like this smooth curve. But anyway, we now have our plot DF3.
For the unique, is there a pros and cons to using that compared to the concatenate?
Yeah, actually, that I always advocate for not manually doing anything ever. For example, I guess I can't pull it up if it's on. So what I was about to pull up is on this manuscript that I'm working on for this replication that I did. It's the same thing as like using this for getting plus and minus 1 standard deviation instead of manually concatenating and putting those values in. So you write up, you have several hundred lines of code for this analysis that you're going to do, and then you collect more data. Or maybe you check your model assumptions and realize like, oh, wait a second, or your case analysis, and you're like, oh, wait, I need to pull this person out. Or, oh, this person isn't eligible, like they don't fit into, the population that I'm going for. So now you need to take this data point out. Well, now, if you manually put in like, 15 point whatever and 43 point whatever, that's no longer plus and minus 1 standard deviation. So when you run that code again, it's wrong. You have to go back and change everything that you ever put in manually. You have to update anytime anything changes in your data. If you do it this way, it doesn't matter. You can filter out whoever you want, and when it runs it, it's automatically going to make those adjustments.
Yeah, I got that one, but I was talking about, so when you give the unique versus
for that, it can be helpful because you can imagine that perhaps male and female aren't the only ones, that there's like a transgender option or a prefer not to say option or whatever. But at least checking unique, and then like if you want to just put in the concatenate, that's fine. But just kind of as a practice, I argue that it's always best to like extract information from your data, no matter what you're doing. And so, I guess that.
So unique can make it quicker and give you what you want.
At least guaranteed to always be appropriate for the data.
But if you only want like 2 of those genders, then you could use that.
And if that was the case, if you had multiple genders and you were only wanting males and females, then it's simple. Because when you filter out, the other gender types, when you use unique, once you filter those out, now the unique values are just male and female. But if you do want to go ahead and throw in those, transgender, prefer not to say, blah, 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 whatever, then it's there because you're just extracting from the data instead of manually doing anything. And so like it's just a good practice overall that'll help keep things more stable generally. And it's just a good practice. So we now have our plot data frame where what we want to do is take this sex by class model, mod SXC, and we have our parameters for this. And so we know like what the coefficient is for males and for first class. And so we want to multiply, you know, this by whatever the male parameter is, and this by whatever the first class parameter is, and get our prediction for males in first class and that standard error. So we have predict GLM and for mod SXC, but we now have to tell predict to make the predictions in some new data. That new data is our plot data frame. So we say plot DF3. Since what we're interested in is we're making a probability plot here, which remember, probability plots, it's the only space that you can see the raw data. So anytime you're putting the raw data points, like you are making a probability plot, and when you're making a probability plot, you just have to put type equals response. And that's how predict knows, like I want you to output the predicted probabilities for these specific values. In this case, what is the probability of males in first class, of females in first class, of ... And then you also have to tell it that SE fit equals true, which is how you get it to output those standard errors. So now if we just run this line,
What about family? Binomial family.
That's all up in the model itself. And we have class is a factor, but numeric was supplied. Oh, right. So here it's telling us that it's expecting a factor because in the model it has a factor. But here a numeric was supplied.
So what's the factor names?
So, well, no, but what I need to do is down here now I have plot DF3. Because if I look at my structure of plot DF3, sex is a factor, class is an integer. Class is not a factor, but it should be a factor because it's a factor in the model. So I just need to change class to a factor. So I'll just say Titanic class as factor, Titanic class.
Wait, didn't we change
Oops.
class to factor up?
Sorry, no, my bad. It's in the plot DF3,
Okay.
not the Titanic. It is already a factor in the data, which is the problem, but
So
it's not
change
in
it back
this.
to the integer?
Yeah. So now when we look at our structure, both sex and class are factors. And so now if we come down here and run our predict, it gives us our predicted values and our standard errors for each of these 6 groups. But that doesn't do us any good because now we don't have like what those original values were. So we need to bind it together with the original data frame, or with the original plot data frame. So plot DF3, predict GLM. And now it outputs, you know, each of the predictions that fit the standard error. And so we will assign this back to plot DF3. And so now if we look at our plot DF3, we can see we have males first class, what their prediction is, what the standard error is. Females first class, what the prediction, what the standard error is. And so now we have our base plot. And so now for our predictions, for those things that we're interested in, we have all the information that we need here in this data frame. So everything else is going to come from here. So let's start by first putting in some points for what those actual predictions are.
Sorry, Austin, can I pause you?
Yeah.
Here, so that's when we were doing this predict GLM. We got our we got our fits and our SE fits,
Mhm.
our residual scales, that's what that outputs. Right?
Yeah.
And then so we need to take that and combine that with our plot DF3 data frame and restore that again as a new plot DF3.
Yeah, because just the predict function itself, it will just output this right here. It'll output the predictions and the fit, but it doesn't keep it with this information and we need these two things. So by binding it with that, we now take the original plot that we made here with the expand grid, or the original data frame, then we bind that with this information to make this one data frame now. That now in over here for our geome point, we'll say that our data equals plot DF3. And then for our aesthetics, X is going to equal, we have sex.f, and our Y equals fit. Color equals class.
Wait, sorry, what are the points again? What's like, why'd you do a genome?
Because this is for like what the predicted probability is for first class right here, second class right here, and third class right here.
Gotcha.
Let me size those up a little bit. Make those a little bit bigger so they're easier to see. So now you can see, like, here's the each thing. Now, the next thing that we need is our error bars on those predictions. So we'll say geome error bar, and again, our data is plot DF3. And then for aesthetics, our X equals sex.f, Y equals, now, remember that what we have is the standard error. Standard error times 1.96 is the 95% confidence interval. So if we just say, well, first of all, for this error bar, we have Y min and Y max. So if we just say that our Y min equals the prediction minus the standard error, and the max is the prediction times the standard error, then what our error bars are showing is the prediction and the standard error. If we do the fit plus 1.96 times the standard error and fit minus 1.96 times the standard error, now that becomes the prediction and the 95% confidence interval. So for our Y min, we're going to say that Y min equals fit minus 1.96 times SE fit, and Y max equals fit plus 1.96 times SE fit. And it's going to give us our error bars. Now, just the default is really ugly. You know, we've got this really wide bar, so let's change the width of those and drop that down to say 0.1, see what that looks like. All right, so that's reasonable. And let's say we also want to color these lines by the same class colors. So now we have all our predictions. Now, as far as like being able to offset these things, let's see if we can figure out how to make that happen. You know, I suppose one way of doing it would just be to offset all of them. Plus 0.3.
Would you do that in the, not in the aesthetics?
No, it would need to be in the aesthetics because you're telling it that my X is this value, but offset.
Would you need to do it to the GM jitter one too then?
No, not to the jitter one.
Kind of moving away from the.
But this is, I'm just kind of working through this because it's reading that as a factor, and so offsetting that. See, this is one of the weird things that can be a little difficult. Let's try. Let's see. What if we? How would that be? I wonder if I just to try something here. If I do x equals I don't know what this will do. Nope. Oh, because then I need six values for it. All right, cool. So that's something that's possible. If we have this, all right. So now if we do, so it's 1, 1.5, and 2. So if we say that this is 1.2, 1.3, 1.4. And that's those three, and then this we do 2.2, 2.3, and 2.4. Okay, so then that's just that one, 1.1, 1.3. Okay, see, and so, I mean, this is actually a good demonstration as far as having to figure out when you do have to like get in here and manually figure things out. It can be a little confusing because, like, basically what I'm trying to say here is that for these points, like, I want, some value of x to be at, like, if this is 1 and this is 2, like at 1.3, 1.4, and 1.5. But what you can see here is that it's not like for females are the first 3. Basically, female first class and male first class. It breaks it down by class first. So in other words, what I'm getting at is by playing with this enough, let's say we do 1.3 and 2.3, then 1.4 and 2.4, and then 1.5, 2.5. Let's see what that looks like. And now we've figured out our things, except they're backwards.
Yeah.
So, okay, cool. 2.3, 1.3, 2.4, 1.4, 2.5, 1.5. And then add this same thing down here for these.
I'm just going to have parentheses to the 1.5 on the bottom.
And now we were able to manually offset these predictions that we were looking for. So, like, it can be confusing depending on what it is. If we were only showing, for instance, if we look at what we did yesterday, like, this one was easy. We didn't even have to offset it at all because there were only 2 points for each one, and just the way that it visually was laid out, it wasn't necessary to offset by any ways. That's not the case with this particular visualization that we were trying to do. But you're able to work your way through it and just think about, like, okay, what am I trying to show? I'm trying to show a prediction and a confidence interval for like females and males depending on class. And by working your way through it, as long as you have that plot data frame, you just have to figure out how to tell ggplot how to show things. And sometimes it does just take working through it manually, especially when it comes to stuff like this, where you're having to figure out, okay, well, how, in what order is R reading these things? Last week, I mentioned, I had mentioned that, you know, sometimes what I find easiest to do, if you're having a hard time figuring out what's what, for instance, one thing that you could do is say scale, color, manual, and then just put in, let's say red, blue, and we're going to put in 6 values: green, black, purple, orange. Oh. Spelling helps. Oh, because I colored it by class. Not the other way. Yeah, well, I suppose in this case, what I might do, because basically what I was going to do was say, like, if you color each of these dots a certain color, and then you're able to see, like, oh, so if I put in red, blue, green, purple, orange, black, and then I see, like, oh, the orange dot, and orange is the 5th color in that thing, then we know that, like, oh, the 5th thing is this dot. In this particular case, because we're just breaking down by one factor that's faceted, another way you could do it is if you facet the entire grid by gender, that might help out. And instead of having one plot where you're breaking off of 1 and 2, like everything is just off of that same thing. But anyway, point is that as long as you get your plot data frame, your prediction data frame set up, then you can think about how you want to visualize whatever it is. Let's look at, yeah, so let's put, let's do age on the x-axis and make different predictions for each class. So again, we got ggplot, Beam Classic, and that's just my personal preference. And then we'll have geom jitter. We're just building our base plot. We know that data is Titanic. And for our aesthetics, X, we're going to have age, and Y is going to be survive. And let's color it by class. And so when we run that, like initially, you know, it's ugly. Like there's not a very clear distinction there. So let's drop down that height a little bit. Equals 0.1. Cool. And then like this overlap, are we missing information visually? Well, let's add our alpha. Cool. So now we have our base plot that we're going to work from. So I'm going to come back up above it, and what do we need to do next to create these? Like we want to show models for the probability of each class as a function of age. So what's our next step here now that we have the base plot?
Expand grid with age class.
We're going to make our plot df4 with expand grid. And we need predictions for age, in which we need a sequence from the minimum of age.
Now, age here is a numeric, no, it's a character. Wait.
And then for class, and so now we have our plot data frame where we have all of the ages for first class, all of the ages for second class, all of the ages for third class. And now we find what was our model for age by class, mod AXC. And so now we're going to come down here and we do the same thing that we did before. We need to find plot DF4 with predict GLM. We tell it what are the model we're wanting to use to make our predictions. We tell it what data we want to make predictions on, which is that plot data frame that we just created. We want probabilities, so we need to tell it type as response. And we need to tell it that we want our SE fit. And so now when we run that, it will give us all of that information. So we'll store it as plot DF4. And so now we'll come down here and we'll tell it that let's start by making our prediction lines. So we're going to tell it geom line, our data equals plot DF4. For aesthetics, our X is going to be age from this plot DF4. Y we want to be our fit. And then go ahead and color it by class. And if we just look at that, we have our 3 prediction lines. And so then we want to add in our confidence intervals. So we add another layer and we'll say geom ribbon. Data is plot DF4. AES X again is age. Y min again will be fit minus 1.96 times SE fit. Y max is fit plus 1.96 times SE fit. And when we run this, it's going to be opaque because I didn't add any alpha to it yet. So if we just ran this, so what's the problem here? What did I not do? Why is it looking like this? Exactly. I need to add in here that my group, not just my color, but group equals class. So now I've got this opaque thing. And so just remember that the transparency is your alpha. So up here, I'm going to add alpha equals 0.2. And there we have it. So now we have our predictions as a function of age and class. Like what's the probability of any passenger surviving the Titanic? A few other things that I talked about yesterday here in these last few minutes, because we got a little more involved with a few things, and I just talked a little bit about the way that I plot things. So as far as making things pretty, let me get out of that one. So if we're looking at this plot that we made yesterday, the few things that I want to talk about, one is I really like the manual adjustments to things because it makes it very easy when every single time it's always the exact same. Like you start by you put scale color manual, whatever you put in first is what it's going to change your legend title to. So instead of being sex.f as the label over there as the title of the legend, You can change it to sex. And then you specify whatever values you want. You can specify whatever labels. So here, it's the same thing. Remember that it's lowercase male and female in the data. So by changing the labels here, I'm able to specify what I want my legend to look like on top of what I want my plot to look like. The other thing that's nice about this, and the only reason I also broke it up by color and shape, was to show that here, if I didn't use this manual thing, so here, notice how it gives me one legend for the shape and one legend for the color, but it's the same variable, but ggplot doesn't know that unless you tell it somehow that it's the same variable. Well, the way that you can tell it that it's the same variable is that if the title that you put in and the labels that you put in are the same, now it recognizes that, like, oh, this is the same thing. So instead of having one that shows shape and one that shows color, when you use the manual and you set the title and labels to the same, it will now combine them and show you. It's hard to see here. You'll see it if you download the script itself, but there is a little triangle here and a little circle here, or triangle here and circle here. But so it knows to combine them. So it shows like green circles is female and purple triangles is male. So that's one nice thing about this. As far as labeling things, I just always use labs because it makes it really easy. Like if I'm just doing down and dirty plots, it doesn't matter. I'm not even worried about adjusting my titles and stuff. But whenever you are like making that finalized plot, you're trying to make it pretty, it's easy. You just say your title equals whatever, your x-axis label is, something else. Your y-axis label is blah. If you have a caption that you want to put on it, then it's just a caption equals. There's also subtitles. So if you want like a main title and then in smaller font underneath that, some sort of subtitle, like that's in your labs, and you say subtitle equals whatever you want it to be. I want to reiterate something that Patrick talked about this week, and I know I've talked about it a lot, as far as like, don't feel like you're not good with R because you're having to Google things, because 100% like everyone Googles things. There's way too much to possibly remember just to be able to sit down and work through a whole script without having to Google something. But the more you use things, the more you retain. For instance, like these are specific things that I do remember off the top of my head now because I've been doing this long enough and making these specific graphs. So for instance, like adjusting your legend position. If I just take off this entire theme and run it, it'll be a quite different plot. We have default, your caption gets right justified, your title gets left justified, and your legend is off here to the side. Well, this is bad because this is an awful lot of wasted white space over here. And especially considering that you have all this white space. So by changing your legend and just shifting it onto the plot, it will expand, and instead of all this being blank, you can make your plot fill up this whole space. So that's just here in your theme, tell it legend position. And you can give it 2 coordinates, which start from this bottom corner. That's telling it to go 90% over and 60% up. So if I run just that portion, so it's ignoring this stuff down here and only running up through legend position, you can see that now it's moved, like the graph goes all the way over, and it put the legend 90% over from that bottom corner and 60% up. If you change this is another one that like, it took me forever to realize like, oh, it's relative to that bottom left corner. And so if you put 0.5, 0.5, it just puts your legend right in the middle of the screen. But what I would have to do for the longest time is say like, okay, let me put one of these at 0.9 and one of them at 0.5. And so once I do that, and see what it looks like, go like, oh, okay, so that first number is where it is along the X, and that second number is where it is along the Y. And from there, dial in and just make it look the way I want it to look. For centering your titles, to get that centered, it's just telling it in your theme, plot title equals element text, horizontal justification is 0.5. So justifications are 0 to 1. So horizontal, 0 is left justified, 1 is right justified. For vertical, you have 0 and 1 again. So by telling it my horizontal justification on the title is 0.5, I'm telling it put the title in the middle of the plot. By contrast, your plot captions, the figure captions should be left justified. So I tell it plot caption, element text, HJust equals 0. And that's saying to move that caption over to the left-hand side. But these are the kinds of things that I used to have to Google this every freaking time because I could never remember. Oh, it's plot.title equals element text and then parentheses HJust equals whatever. And so like once I got to the point where I build my base plot and then build whatever, and like the last thing that I worry about is making it pretty. And once I get there, I just Google ggplot center title, and you'll guarantee that the top result will point out that it's just here in your theme. You have plot title element text HJust equals 0.5. Cool. Copy and paste that in. Now I'm good. And so working your way through these graphs and just breaking them down to their individual components and just taking it one piece at a time and saying, I want to do this. Like, how do I do this one thing? And figuring out, like, cool, check, got that. Next step. Now I need to adjust this. But ultimately, I would encourage you, I'm going to post both of these scripts, and I would encourage you to look through them because we did show different plots of even the same models, but whether you're modeling it this way versus having the plus and minus 1 standard deviation of something, because Patrick's talked about like there's no one right way of making these plots. It really depends on what you're trying to show, and so that's just what you have to do is you have to stop and think like, okay, what is it that I want to be able to visualize here? And you start with that, and then you see like, am I able to see this comparison that I'm wanting? Whether or not you facet this. So here I took off the facet. It might be better. Like you might be better off by faceting it by sex, depending on like, is the comparison that you're trying to make something that is easier to make if they are on one plot? Or if you have it all on one plot, is there too much overlap and it makes it hard to distinguish what it is that you're trying to show? So just thinking through, like starting with like, what do I want it to look like? And then kind of reverse engineering and taking it one piece at a time is the key to being able to make these graphs. But that's the beauty of ggplot is that it is 100% customizable. Like you can visualize anything you can imagine. You just have to work through how to actually do that. Do y'all have any questions? Yeah, what's up?
I have 2 questions. So first thing I'm confused on is the AES X equals and then variable, and so you change that to numbers here, which makes me wonder, what is that X referring to?
So what that's referring to is on that plot, even though this is a factor, like it recognizes that these factors are 1 and 2. So if I just change this and I said, the reason I did this is because if I just said X equals sex F, then basically it sees all of these as 1 and all of these as 2 because they belong to that group or that group. And it will put them all directly centered there. So like these will be directly overlapped with one another. So I needed to be able to offset them by different increments. And so I just manually specified where I want to offset them by. And it might, if we made this width less than 0.2, because again, that 0.2 means that it's allowing it to expand out from that center line by 0.2 units. So this is 1.2. So if I had made that 1.2, this dot would be right here in the edge of that. And so just being able to manually specify where do I want these points to show up.
Okay. So for the dichotomous are automatically makes it 1 and 2s, or is that?
It being 1 and 2 specifically might be a function of what is in the underlying data, that if you recode that factor and set the values, like the labels to male and female, but set the values to 0 and 1, then this might be 1.3 and 0.3 and 1.4 and 0.4. It just, but that's, I mean, you saw when I worked through it, like I just had to start with a point, look at it and see, okay, what's going on? Ah, okay, so I can offset these this way. And then it's a matter of like figuring out, well, what order does R read these in? So you just pick an order, look at the result and say, ah, okay, so now I need to switch these around. It's the same thing, like if you're ever trying to manually make a matrix, that's always a nightmare for me. And remembering, like if I'm trying to make a 3x4 matrix and I have 12 values, like do I need to put in like the 3 values I want across the top row, followed by the 3 values of the next row, or does it go down columns? So I need to do like this value, this value, this value, this value, then this one, this one. Every single time I screw that up. And the only way I'm able to figure it out is by trying something, seeing what the output is and going, oh, wait, no, I need to flip this around and do it like down the columns instead of across the rows for the values that I'm trying to specify. So like really and truly, when it comes to like programming, programming languages and using R, like one of the biggest things is how good are you at troubleshooting problems? Like that's really what it comes down to, is trying something and figuring out like, okay, what am I going for and what is it outputting and how can I make those two things line up? So you try something and try something else.
My second question, and I tried to ask Patrick, but I don't think he understood. So if you go to our last graph that we made, I'm wondering how to go about intuiting how to understand what this graph is showing. So like our plot DF4 graph. So like it seems like the data are like clustered together in certain areas compared to the other category of survival. So like what are we?
So what this is showing is that in general, as age goes up, the probability of surviving the Titanic goes down. Like ignoring gender and only looking at class and age, that as you get older, it's less, there's lower probability that you're going to survive the things. And you can see, like if you're 60, like the probability of surviving if you're in first class is about 0.4. If you're in second class and you're 60, the probability is, you know, maybe 0.3. And if you're in third class and 60 years old, you have like, you know, 10% chance of surviving. So that's what this is showing, like what based on if you're in third class, you know, but if you're young, like you have a better chance of surviving than if you're old. But there's an even bigger contrast up here. And so that's really what you're looking at. Like this line is the probability of surviving based on some age and what class you're in.
So if we didn't have those lines then, and just looking at the dots, you would intuit that by saying, because there's more dots around not surviving near the age of 60 and up compared to the surviving group, that's...
Yes, that's exactly what it's doing. It's comparing like this chunk of data to that chunk of data and seeing like, well, you know, more people didn't survive in this group than did, or in this group, especially like if you're looking at first class females, like more of that group survived than not. So the probability of surviving if you're a female in first class is higher than, you know, a male in first class. But in a first class female, there's more dots there than when you look at second class, where like perhaps it's a 50-50 split. So you have a 50% chance of surviving if you're a woman in second class, whereas if you're a woman in first class, you have a 70% chance of surviving, or whatever the numbers break down to. But yeah, in general, that's what we're looking at. Anything else? Cool. Well, I will get these posted. Both of these scripts, I am completely